So we're in section 7.3, assessing normality. And the section's about normal probability plots. And a normal probability plot is a graph created from the data and the ordered positions of the data. And it enables you to tell whether the data could have come from a normal distribution, or the ordered data are plotted against where they would lie in a theoretical normal distribution. If the data came from a normal distribution, the point should form an approximate straight line. Departures from this straight line indicate departures from normality. The details of the concepts behind the procedure are kind of outside the scope of this class, but the procedural details of how you actually construct the plot, we can handle. So we'll try to do that. Here we go. Actually, maybe we'll look at some example plots before we try to make our own. I guess that makes sense. So here is an example of a normal probability plot. Upstairs is the histogram. Clearly the data is skewed to the right. And then here's the probability plot, these dots. Now, they're supposed to fall in an approximate straight line if the data was normally distributed. That straight line here is indicated by the center line. And we've got these curved error bars around the line. If the data came from a normal distribution, the way the computer produces those is supposed to indicate where the data would fall. If it came from a normal distribution, it should be trapped in there most of the time. So you see these values escaping. That's a bad thing. And here's some other ones here. The outliers there escape that pattern of these two curved error bars. And overall, the shape of the graph is supposed to be approximately linear if the data came from a normal distribution, and it's clearly curved. We could make even more conclusions about the data. This is the data axis here. So this data value here corresponds to, this dot here, say, corresponds to maybe a data value of 0. And there's some zeros here. They've been collected in a histogram, so who knows? Maybe there's a bunch of values in there. It says there's maybe 11 in there spread across that range. I guess one of them is pretty close to 0 because that's this dot here. The other ones are close to 0 too. And what the probability plot tells you is how you would want to move the data from their current positions on the number line to create a normal distribution. So this value here, which is at whatever percentile is listed on this axis, should have been dragged over this way, like this. All these small values should be dragged over that way to create a normal distribution. And then these two outliers also should be dragged this way. And if we could have done that, then the overall pattern will be approximately linear and the data would look normal. And what happens when you do that is these outliers get removed and dragged over that way. And some of these values here get dragged over, so the histogram ends up having a more bell shape. And so the probability plot tells you how you had moved the data to make it bell-shaped. And in particular, judging from what we did here, these values have been pushed over that way, and so are these. So you take a symmetric distribution, squash some stuff in, squash some stuff over, and that makes it skewed to the right. Now, if you started off with normal data, which this is, then you get this pretty close to a straight line graph, and most of the values are supposed to stay between these error bars. When you look at a graph on your calculator, you can't see those error bars. They don't display them. But we'll see another technique that we can use to determine whether the data seems to be normal besides these bars, which are useful in a more fancy display. We're looking for that straight line if it's normal. So here's some data. And as long as we have data, I thought we might look at some graphs we can do with those data. So here we go. I've, in theory, added these data points into my calculator. So stat, oh, on first, stat, there it is. So over here in list 1, maybe I'll zoom in a tiny bit. Okay, this over here. Over in list 1, I have the values 1, 12, 14, 16, 17, 19, 21, 24, 28, 32, 37, 1.5 like that. Okay. But having trouble getting everything in order. You might, I set this up, but I set it up, I made a typo there. Okay, fine. And over on list 2, I've got the ordered position. So this says the first value is 10, the second value is 12, the third value is 14, and I should triple check that. Things have been going wrong for me. Fourth value is 16. Fifth is, okay, it looks good, okay. And then we're gonna go into stat plot. Okay, so stat plot is here, second stat plot. And then we'll just turn one of the plots on, just hit enter. You can scroll around, make different things highlighted. I got this plot 1 highlighted. I'll hit enter, and I'll go down to type. I'll pick histogram, hit enter, and we'll go down to this color code, and hit enter again. And now you notice with stat plot, it doesn't draw anything. You have to go to graph. And then ordinarily the window's not set right. So then you can go to zoom stat to help you out. And there you go. Zoom stat, looks like that. Is it the right stuff? Let me take another look. Second stat plot, it's on. Yeah, list 1. Fine. Let's try quitting that. Let's try setting the window to a different size window. Let's go from 5 to 60. Then we'll hit graph, see what happens. There we go. So the other zoom stat didn't quite catch what I thought it should, because 10 was there. It wasn't showing me 10. That's funny. I'm going to go to window again. I'm going to make it 0 to 60. Ah, beautiful. Okay, so there's our version of the graph. Zoom stat should have taken care of it, but it didn't seem to do it. There we go. Anyway, there we are. It's not exactly the same histogram because of slightly different bin sizes. So this has divided the range into about 8 pieces, and this is divided into about 6 pieces. It just does what it does. All right. So that indicates, well, maybe we've got the right data in there, who knows. And then we're going to go through a process that looks like this. So we're thinking about how does this work. So what happens is, on this left-hand side here, these percentiles, they're scattered in a funny way. If we wanted to use a real axis for an actual number line instead of these percents, you'd go through this process. The left axis is actually the expected z-score for a percentile equal to this quantity. Here I represents the position of the data. So we have 1 through 12 showing up for I. And then we compute a percentile. And then we look at the z-score table backwards to see what z-score would have produced that percentile. Our calculator has a way to do it, all right? So we can look in tables backwards, or we can use inverse normal on your calculator. I'm going to use inverse normal on my calculator to do it. So let's see how that looks. Okay, so here we go. So second quit. So the first thing I'm going to do is look at it, stat edit. So list 2, I've got the position. So these are the I values. So I'm going to put list 2 minus 0.375 and divide by 12 plus 0.25. I'm going to stick all that stuff in list 3. So here we'll quit here. So I go parentheses, we take list 2 values, those are the I's, and we subtract off 0.375. And then we divide by 12 plus 0.25, like that. That's looking good. And I can't forget, I'm supposed to store it somewhere. Store it in list 3, like that. So that'll give percentiles that we look up normal distribution values for, so that the area left are these numbers. Did that? See what they are. So here are the percentiles: 5%, 13%, 21st percent. So those percentiles are what we're going to look up z-scores for. So what z do you need to be at the 95th percentile, right? So we'll try that. And so just for example, for the f equal 9.949, we'll see what the z is. So where do you find that? You go to distribution here, so second bars, and we go down to inverse normal. I'm worried I might be in my table right now. I guess I'm okay. I'll put 0.9490 there. And then I want that to be the left tail from a normal distribution that has mean 0 and standard deviation 1, a standard normal. Now here's paste where it might paste it in the wrong place. I'm scared now. Oh, it did. Okay. So it's trying to make that, I'm going to quit this and fix it. Add, edit, and I'm going down to where that 949 was to make sure I didn't screw it up. Yeah, I screwed it up, okay. 0.9490. Okay, it's back in there. And I'll make sure I quit this time. Okay. And then I wonder if I go second enter, whether it'll type it for me. No, I don't want to do that. Okay. Clear, clear, clear. So I go second distribution. I go inverse normal. I go there. 949, paste, hit enter. And I get the z 1.6352. So what that says is, if here's a standard normal, which I'm just sketching out here, if I want the position, so this is 0.949 here, that position is 1.6352, like that. So you could find that in the tables by hunting for 0.95 and then finding the z that goes with that. I think for 0.95, I think it's 1.645, but this is a little bit 0.95. So that should make us actually pretty close to the same one. Let's take a look. So 0.95 is 1.645. That 95 is a tiny bit bigger, so we move over a little bit. So that kind of makes sense now. I was worried for a second. And here's the table, so we might look for 0.949 in it. So somewhere in here, that's off by 0.5. That's off. I guess I'd have to take this. 1.64. It's kind of the best we can do in the tables to give to, I'm reading it here. 1.64 up there is the z that gives me a percentile about 0.949. So that's what inverse normal is doing for us, is using the tables backwards. Okay. So that explains that number. And then if you want to get a lot of these numbers, the fast way to do it is to go second enter like that. And then you can go ahead and type other numbers in there. So you go, that's inverse normal. Come back here and pick something else. I think we had 0510 as one of our candidates. And hit enter for that. And it gives me another number, the positive one. So those are the two tails. So over here, if I want 0.051 showing up there, this is minus 1.6352. So I guess my graph should have just come down a bit harder like that. It's pretty hard to draw it. Okay. So if we just keep going second enter like that and adjusting this number, eventually we'll fill out this whole table. And it looks like this. So let's take a look at what's in the calculator right now. Stat edit. Okay, so what I've got in there is I've got all these values. There they are. And then what I have to put in there are these happen through list arithmetic. I tried using list arithmetic to make this happen, but since it has that paste feature, it's just not going to happen. So I'm forced to type these. So what I'm going to do is I'm going to stop recording and type them and come back.